People ask me, how did you become interested in researching materials? And my answer is that I basically wanted to face my own ignorance head on. Now, might sound a little surprising. Aren't architects supposed to know about materials? I mean, after all, it's what we build this world with. It's our palette. And my answer would be, well, yes, of course, but the traditional kit of parts is actually quite simple, and it's pretty limited. We've got wood and glass, concrete, steel, etc. Now, of course, we have a lot of varieties within those categories, but not a lot has changed until recently. And what we're seeing now is a dramatic shift in the products and the resources that are available and that will affect our physical environment. James Timberlake has said that in the last 15 years, more new products for buildings have been created than in the entire previous history of architecture. There are others that make similar claims. I don't know how we can possibly quantify that necessarily, but technology has an arc, an accelerating trajectory, and materials follow that largely. But really, why is this? I mean, it's an interesting question. Why is this phenomenon happening? And another question would be, who cares? What do we do with this stuff? These are a couple of burning questions that I've been interested in answering over the past few years. And so what I'll try to do today is very quickly go over a couple of the trends that I deem to be important, and then show you with physical evidence some of the interesting innovations that people are creating. The first trend is simply following our past set of lectures. Energy is clearly a hot topic nowadays. Another reason that I would claim that fossil fuels, that our current energy crisis with them is not our parents' energy crisis. It's not any previous generation's energy crisis, because what's interesting about it to me is that I feel like we're still enjoying the party that the founders of the industrial project began, right? We're still making stuff with heat and pressure and treating it. We're still forging it. We're still using fossil fuels. But more importantly, our very livelihoods, our framework, modernism, is founded on petroleum, by and large. And this whole framework is about to change. So what's interesting to me about this, whether we think that peak oil is going to happen tomorrow or in 5 years, is that we get ahead of the curve. And this is perhaps oversimplified thinking, but I tend to think that way sometimes. I like to think that all of this storage, all of this massive storage of fuel that we've tapped into, that's been storing up over hundreds of millions of years, is going to go by in a snap of an instant relative to that time. I like to think, wouldn't it be nice if that were our savings account, right? We can tap into it during an emergency, but really, wouldn't it be great to tap into renewable energy sources, kind of the daily stuff that hits our planet, the winds that blow, et cetera, as our sort of cash account, if you will. So I'd like to look at a couple of materials that I think are interesting. The first is called Sphelar. It's made by Kyocera. I actually was able to see this in the Renewable Energy Conference last week in Tokyo. What I like about this photovoltaic technology is that it's comprised by a matrix of spheres. Now, why is this? It's because having the technology within a sphere makes sense when light can be captured not only directly from a certain angle of incidence, but also from all angles, including diffuse light, bounce light, that kind of thing. And this can be integrated within a building, integrated photovoltaic panel. The company is working on a lot of interesting devices, some that you can wear, some that will charge your cell phone. This is part of an electrolysis device which, when connected properly, can separate hydrogen from oxygen atoms and needs a fuel, place to store the fuel. Another interesting technology is photovol glass by MSK, another company in Japan. Now, this is more standard amorphous silicone that comes in a sheet form. We see a lot of this. But what I love about this approach is that we're doing double duty, if not triple duty, with a building element. If you think about it, a lot of solar panels or technologies are added on to our buildings. But doesn't it make sense that we integrate that technology with something we're going to build anyway, like a curtain wall of glass? And what I like about this is that if you think about it, if you want to generate some energy for your building, you place this material where you get the most sunlight, which makes sense. Well, that also happens to be the area in the building where you get the most energy radiation. And in office buildings around the world, there are shades and mini blinds drawn and often left that way on the southern facade, if we're in the northern hemisphere, of course. Well, this material, you can tell it blocks out part of the light, the visible light. So it's naturally in the place where you'd want to shade, and it's generating energy. The other thing that's interesting about this technology is that it's made so that it will actually hold light, so that it can be for large-scaled multimedia displays at nighttime. Now, we have, obviously there are so many power generation technologies being developed. Well, it stands to reason that we will also need to be mindful of insulating and conserving that energy that we store, or that we harness, rather. And this material, you've heard of it called Aerogel. This is nanogel by Cabot Corporation. And what's exciting about this material, it's a NASA material that was made for aerospace purposes decades ago, but now it's hit the consumer market. And incidentally, all of these materials will be on display, I believe, on the third level tomorrow, so you can touch and feel these things. But these pellets are the lightest human-made substance on Earth. They're 99% air and 1% quartz. Now, what's nice about that? What's nice is that when we fill a cavity, in this case, it's a polycarbonate sheet, with this material, we create a light-transmitting surface that has the same insulating properties as a well-insulated wall. So what does this mean? Well, what it means is that it changes the paradigm of where we have solidity and transparency, or at least light transmittance in buildings. Historically, wherever we put a window, we have a leak, right? It's a sieve. So architects are constantly dealing with the balance between, well, I really want this to be transparent. You know, these office workers need daylight, they need views, but energy codes, and it's a kind of interesting environmental battle that's happening because, of course, people understand the need for light and view, but we're losing energy out of these windows, or we're getting too much solar heat gain. Well, what's great about this material is it changes the equation. Now, it's not transparent, but you can now feasibly have a building that's all light transmitting. You don't have the same argument about what's opaque and not. Now, the next material I'd like to talk about, really it's the next topic, really, is, and again, I'm really generalizing here, but resources in general. Lester Brown didn't talk about this earlier, but in his book, he does discuss that we have some very close time horizons for using up several key minerals, like bauxite for aluminum, iron ore, lead, copper, etc. I think the horizon for those, we will deplete virgin materials within anywhere between 30 and 70 years. Now, 70 years is a ways off, but it's actually not. Now, those are known stores of materials. However, gives us cause to think about how are we going to construct our physical environment in the future with those virgin materials. So clearly, there's a huge movement. We're all aware of it, and recycling, salvaging, reusing, etc. And there are some interesting products that have been developed that turn waste into art. The first one I'd like to talk about is this very interesting, almost biomimetic looking lamp. The folks at Pad Lab have also developed various different sculptural pieces. With the stage lighting, you can't probably see this light too well, but what's great about this is it's a very interesting, almost kind of biological sculptural element that is comprised, the idea of, it's comprised of drinking straws. So this notion to reuse an everyday object instead of trashing it in the form of something like this is pretty inspiring. The next product I'd like to talk about is this over here. Eva is a series of vases and other objects that Tony Verman in New York has made with hot glue. Familiar with the hot glue guns? This is an industrial byproduct that he's been able to transform into, I think, pretty stunning products for the home. Let's see, next we have, you've probably heard of Kirei board. Kirei in Japanese means beautiful or clean. There's a lot of, we use a lot of wood in construction, obviously. There's a lot that's used for sheathing and cladding, as well as framing. And this material uses the reclaimed stalks of sorghum. Sorghum is a food source in many countries in the world, and composes it in a panel format that obviously is an attractive material that can be used for vertical as well as horizontal surfaces. And is a nice substitute for virgin lumber. Next, we have, this is Squawk Mountain Stone. It's made close to Seattle. And it's an interesting paper cement composite. So reusing waste paper and mixing it with cementitious, in a cementitious matrix. It looks like stone or concrete. It's actually lighter than either, and it doesn't require reinforcing like concrete does. It has a nice tactile quality to it. The next material is called Alchemy, and the idea is a simple one. Again, make waste into art. This idea was essentially to take aluminum waste scrap, industrial scrap, and collect it off the factory floor, put it in a resin binder, and you have an amazing countertop surface or wall panel. So again, we're seeing just the surface, really, of products that, and here's another sample of Alchemy in a different color, that take waste and make amazing objects out of them. So again, I mean, obviously downcycling is a concern, but if the trade-off is downcycling versus in the dumpster, I think that's a trade-off we can make. Next, I want to talk about only one element of globalization. Obviously, it's a pretty controversial topic. And what I'd like to talk about is the kind of homogenization of the globe, the franchise effect, the sort of downside of widely networked commerce. And the reason that I bring it up is that there are several designers and material manufacturers who are making materials in response to this effect. They're trying to make materials that either change the way we think about something or make us a little scared or interested, as well as materials that respond to us. And so the first material, it's a little tongue-in-cheek because the glass, in terms of the theme of the conference, dangerous ideas, a glass stair. Now, obviously, we've all been on a glass stair before, but what I like about this product is that Nathan Allen Glass Studios has developed a tread material, which they call glass sandpaper, which makes this more viable, and because of slip resistance and that kind of thing. And the other reason I bring this up is not just because it's not the typical floor that we would walk on, but that it speaks to another trend that we're seeing in materiality, which is dematerialization. Seems sort of counterintuitive, the dematerialization of materials. Transparency, higher strength to weight ratios. We're seeing all surfaces of buildings become more light transmitting, and it's an interesting trend. Next, we have a couple of materials that are responsive. So they change based on our relationship to them and the relationship of light. So this is Sensitile, developed by an engineer and architect in Detroit, Abinand Lath. And it's really a beautiful matrix of acrylic. He's done a whole, many different varieties of this technology. With the right kind of light source, you can see that this uses basically the same principles as fiber optic technology. And so with the right angle of light, you can see that my hand is creating shadows that ripple through the tile remotely, so from other angles, and color can be conveyed as well. There's another sample here, which is heavier. This is Sensitile cast in a concrete, terrazzo, and I want to show you the back here. Okay, the back is opaque, and I hope you can get this effect. But when I run my hand, you can see the pixels, if you will, turn on and off. And I hope you can see this. You see there's light in the shadow? Now there's not, now there is. How does that happen, right? We can now put light and shadow. Now, why this is interesting is not only because it would make a cool nightclub, maybe not if you've had too many drinks, but this idea of migrating light where it isn't is fascinating to me, because on a building scale, we can literally move sunlight, natural light that we don't have to pay for and we don't have to pay to cool our buildings because we have artificial light. We can move it into places that need light. And we can move it in a much more dynamic and interesting and reactive way. The next material within this series is called Living Surfaces, made by B-Lab in Italy. And these are a couple of floor tiles here. They're normally meant to be placed horizontally instead of vertically, but I think they're still beautiful. I can walk on them. You can walk on them later. You won't see me very well if I do now. But this material uses a couple of layers of acrylic, and obviously has the right slip resistance and everything. Incidentally, this is installed in the many places, including the W Hotel Bar in New York, and people somehow want to gravitate towards this because it's underlit and it's kind of fun. But the idea is that people interact with this. There's a series of tables as well, and kids love to play and interact with them. This is a personal favorite. This living surface is filled with magnetic particles that I probably won't, I need a magnet to maybe test this, but responds not only to touch but also static electricity. So if you're charged, you can actually make graffiti on this floor that will last a little while. So the last trend that I'd like to talk about is another big topic. First, just in a very simplified way, where is technology taking us? I mean, I love technology in some ways, but I think it's important that we maintain a certain critical distance from it. And this is a graph that charts Moore's law, which I extended a little bit. I learned about the singularity first from Stuart Brand. But it's interesting. I mean, not just in terms of computational power, but also miniaturization, distribution, speed, et cetera. Technology is following, by and large, this kind of accelerated graph. And one has to wonder what happens when we're making the same level of innovation every second that we were, it might have taken us a month, every month to make. What does that mean when Moore's law does become Moore's wall? Is there a sort of plateau that we hit at some point? And important to me is, how will this affect our physical environment? How will the speed of technology, the acceleration of technology, affect what we make and what we inhabit? So there are a couple of ways. Again, this is very simplified, but one thing that we're seeing, obviously, is that technology is affecting fabrication. And so what I'm amazed and impressed by is that, we used to have, for many centuries, we had the sort of realm of the craftsperson, right? And the articulation in buildings that went away with mass production of things like sheetrock, took the place of plaster and that kind of thing. What's interesting is the computer is allowing a kind of mass customization to be reintroduced to buildings in an unprecedented way. So this material is a photo etching process. I've got a couple of samples. You can see this one here. This has incredible resolution. This is made by Intaglio Composites. This is not paint. It's not a layer that will wash off. It's for exterior grade use. So you can have a building that is literally all a mural, tiled or seamless tile. What's interesting to me is I'm starting to see in the world, if you think about the old Doom or the old sort of very simple graphics games, which are mainly comprised by sort of tiled surface patterns on walls, we're now seeing buildings. It's like the transference of that virtual effect to buildings, because now architects and engineers can simply work in their box and have someone output it in materials. Another effect is kind of a broad category, for lack of a better term, intelligent buildings. We've heard a lot about intelligent buildings, but to date, a lot of that has been in the wiring. It hasn't necessarily been in the materiality of the building. And I have a product here, which is called Kinetic Glass, developed by a company called The Living in New York. And this is a prototype. Obviously, it's not a consumer product. But if this thing is on, I love this sign. It says, "Breathe here." This particular prototype is developed, without any mechanical motors or other sort of clunky devices, but rather with a series of microprocessors to react to unhealthy air. So if I breathe on this thing, and I'm afraid you might not really be able to pick this up, but it begins to shift and bend. It's sort of like a series of gills. This particular prototype is designed to detect unhealthy levels of carbon dioxide. So the notion is, obviously there's sort of safety purpose, if you will. But what I love about this, and a bigger idea, is that we can now have surfaces that are dynamic and that tell us something about our environment, and that even by moving, maybe in a big scale, this could actually move and actually clean or purify or mix the air a little bit better. And I'm really interested to see where technology takes our buildings from using the same old materials and having more wiring behind the walls to using very interesting materials themselves that move and shift as needed. So in summary, what's interesting is that we're not only seeing a lot of materials, but we're seeing materials across all platforms being developed and scrutinized. People in the design community will agree, I think, that there's an unprecedented level of scrutiny paid to current product lines, manufacturers. You can't open an architecture or engineering magazine today and see the same ad that you did last year or the year before. Whole product lines are being revamped and retooled. So we also, in addition to the new things, we also have all the old stuff being reevaluated based on sustainability principles, et cetera. At the same time, you can see this is a qualitative analysis of materials over time that based on any one given time period, we're interested in maybe certain materials over others. And that's beginning to even out. So we're now seeing an interest in kind of all material frontiers. Now, what gets me up every morning? What gets me out of bed? It's clearly certain materials are phenomenal, and it's obviously thinking about their potential that makes me very excited. But what makes me the most excited is the incredible human ingenuity that is behind all of these things. And these fabricators, architects, designers, engineers, et cetera, are all busily toiling away. One of the benefits of working on a catalog that I've been working on is I've been in touch with these people and hearing their dreams and their aspirations and their struggles and their failures, but also their successes. And what's thrilling is these people are making our future. And it's obviously not all of these things will stick, and we won't see whole buildings made out of all these materials. necessarily, but the idea is that the will is there, the desire is there, and that's a thrilling thing for me. And it doesn't have to stop here, because I believe that it's not just about the design community, especially not anymore. It shouldn't be. It's not just about people who make things or build things. Every single one of us in this room has a stake in the physical environment and the future of the physical environment. And I hope that all of us, it's an opportunity and a challenge, embrace that fact and do what we can to build a better future together. Thank you.